The 12th question deals with finding the number of additions and multiplications involved in performing Gaussian elimination on any n by n upper triangular matrix. So, okay, let's first recall what Gaussian elimination is. So, in Gaussian elimination, what we have to do is basically reduce the matrix to upper triangular form and solve the matrix, right? So that's what the process for Gaussian elimination is. But in this question, they have already given that we are performing Gaussian elimination on a upper triangular matrix itself. So the matrix itself is upper triangular. We don't have to again bring the matrix to the upper triangular form, right? So we don't have to worry about the reduction basically. So we just have to worry about solving the equation, right? So we don't have to worry about the elimination part. So I will solve this with an example, right? So let's consider n equals 3, okay? And let the upper triangular matrix be u11, u12, u13, 0, u22, u23, and then 0, 0, u33. Right? So this is the upper triangular matrix. And since we have to solve this, let's also consider x1, x2, and x3 equals to say some b1, b2, b3, right? So now for us to do back substitution, first we'll consider the third equation, right? So we get x3 equals b3 divided by u33. Okay, and I am considering multiplication and division as the same thing, right? Because when you divide something by something, you're just multiplying it by the so let me so say if you're dividing x by y, right? This is the same as x times of 1 by y. So this is a number again. So unless this is 0, we can do that, right? We can consider multiplication and division as the same thing, and I'll do that for this problem. So in this case, the number of multiplications is equal to 1, right? Just one division. Now for finding x2, we'll have to do b2 minus u23 times of x3 and whole divided by u22, right? This is how you get x2, which implies the number of, and here the number of additions is 0, right? So now for this case, so the number of multiplications will be 2, right? Because there is one that's right here and the division that we are considering here. And number of additions, again I'm considering addition subtraction to be the same thing. This is 1, right? So let me write the totals in a different color. and in this case okay, and next let's do it for x1, which will be okay. So this is a bit complex, but you'll get this. I have solved this on the side. I'm just writing it down from that. Minus u13 x3 divided by u11. Okay, so this is what the equation will be for x1, right? I mean, you can sort of make it out. So u12 is here, x2 is here, u13 is here, x3 is here, and the whole thing you have to divide it by that, right? So it's intuitive. You don't have to worry about it. And in this case, number of multiplications is how many? So you have one here, you have one here, you have the division here, so 3. And number of additions or subtractions is how many? You have one here, you have 2 here, so 2, right? So this is the thing for x1, and here we have a total of how many? 5. Right. So now if we add all of this up, so the I'd say overall total would be 5 plus 3 plus 1, right? Which is equal to 9. So in this case, in this particular case, you have taken n equals 3, and the total number of additions and multiplications, we have gotten it to be 9, right? So which is 3 square, right? And 9 is 3 square. Okay, now you can generalize that, right? So I will say generalizing. So the number of additions is straightforward. So for, I will say xi, number additions is given by, so when I is 1, the number of additions was 2, right? And when I was 2, the number of additions was 1. So, and when I is 3, the number of additions is 0. So I can say that the number of additions is equal to n minus I, right? And if you see the number of multiplications, it is always 1 more than the number of additions, right? So when it was 0, this is 1. When it is 1, it is 2. When it is 2, it is 3. So it is n plus 1 minus I, which is pretty much the same as n minus I, right? Now the total work, or which is equivalent to the overall total that we calculated here, is given by summation I equals 1 to n minus I, right? which is equal to n times of n minus 1 divided by 2, which is O of n square. And hence the answer to this question is B.